Hello and welcome to another Intro to Java programming video. In this video we're going to talk about mixing data types in Java. If you're watching this video, it's assumed that you've already watched the videos that deal with primitive data types in Java and probably also something on variables, and you're ready to dig into this material. If not, you should go back and watch those videos so that you're ready to understand this. Really quick review. Java is a strictly typed language, and that means that every variable that's created has a type defined. In other words, when I make a variable called n, I have to choose what kind of data is going to go into it. I could choose to make it an int, so it's integer type data, or a double to make it a floating point type data, or char or char to make it a character type data. But anytime I make a variable, I have to choose its type. And generally speaking, only that type can go into that variable. There are some things that might be confusing with that, though, because there are times when it seems like I'm putting different types into other kinds of variables. Let's explore that thing. It's called mixing types. Java can mix types, and it only does so following certain kinds of rules. Now, let's go into our variables up here before we talk about how we're going to mix them. I have a byte, a short, an int, a long, and a char. These are all of my integer types. And then I've got my floating point types, a float and a double. Byte is just an 8-bit value. You can go from -128 all up to 127. A short is a 16-bit integer type that can go from -32,000 roughly to +32,000. An int is a 32-bit signed integer, and it can go from -2 million and some change to +2 million and some change. And then a long is a 64-bit integer type that can go from -9 and 9 billion and some change, or -9 to the 18th, all the way to +9 to the 18th. These are very, very large numbers. Now, to express a long is going to look a little bit different than to express any of these other things. Any of these other integer types, just put the number in there. But if you want to express a long, you have to put an L at the end. That's going to prove that it's a long type. Okay? Now I've also got a character here, the A, and characters are always surrounded by the single quotes that defines them as a character literal or a char literal. Floating point types, I've got the float and the double. Float is 32-bit signed floating point type, and double is 64-bit. They are very large, very precise numbers. They can hold huge numbers. I'm not going to go into all the information that goes into what really makes a float and a double. This is not the time to go into the computer science of floating point types. It's a little bit more complex than we're ready for right now, but just know that they hold decimal values. Now, if I want to express a float, I have to put the F after the number. That means that it's going to be a 32-bit type. If I don't do that, it's assumed that it's double. And you can see that I've got an error. It says, found double required float. What that means is that on the right side of the assignment operator, it found a double type variable, but it requires a float because the left side of that assignment operator is a float. So if I want to make it float, I've got to put the F there to define it as a float. Otherwise, it's assumed that it is a double. Let's talk about what happens when we mix types. When we mix types, we get conversions. Data will convert from the narrower type to the wider type. In other words, on these scales here, they'll always go up the scale. So if I had a float and I multiply it with a double, at that multiplication, the result would be a double result. It widens to the broader type. If I was mixing an int and a double, int is considered narrower than double. In other words, it's less precise than a double. It would, at that multiplication, widen the conversion to a double. It wouldn't be an int result. So let's take a look at this. I've got a float and an int added. So I've got a summing operation, f1 plus I1 stored in D1. So here's what happens. f1 is a float, I1 is an integer. It sums these two together and it would give us a float result. It wouldn't give us an int result. Java will not truncate the decimal if we're mixing types like that. It won't allow for narrowing precision or narrowing conversions. It only increases the precision. It will never cut down the precision unless you explicitly do so. And then it's going to store it in this double. So it takes this float result and then it widens it here at assignment into a double. So the result here held in this variable is going to be a double result. Okay, so double precision floating point number. Here I've got I1 plus B1 goes into F1. So B1 is a byte, so it is our 8-bit value, negative 127 all the way up to 120, or negative 128 all the way up to 127, with 0 in the middle and a sign. And then I1, which is my int. Right here, int is the wider value. So this operation would result in an int type, not a byte type. And let's think about why that is. Let's say you've got a box that is 1 cubic meter cubed, 1 cubic meter. And I've got 5 cubic meters of stuff. I can't put 5 cubic meters into that 1 cubic meter box, right? I can't stuff 5 cubic meters of dirt into a 1 cubic meter box. I'll have a bunch of overflow. But if I had a 1 cubic meter worth of dirt and 5 cubic meters box, I could take that 1 cubic meter and it fits nicely in the 5 cubic meters. I don't have any overflow. That's kind of like this. This is my 5 cubic meter box and my 1 cubic meter worth of dirt. It can fit into there. So it always will go to the wider value. And now, ints are narrower in value than a float. So what's going to happen is this int here that resolves from the subtraction of the byte from the int is going to widen into a float when it goes into this variable here. I'm going to run this so you can see. So I've got my my two operations here. This is my first one. This is my sum. You can see that we get our double result. It's got that long precision. And then here we've got a floating point result, negative 115. And this is a float. And you can see it's 0.0 at the end. Even though this is a subtraction that doesn't result, because we're working two integer types, it doesn't result in a floating point number. When it becomes a float, it always gets that 0.0 on it because now it's floating point. Even if there is a whole number here, it's always going to give us the 0.0. Now let's see what this is. S1 gets I1 times L1. It says required short, found long. And let's figure out why that is. It requires a short. What that means is whatever is happening over on the right side of this assignment operator is being assigned into the variable of type short. Okay, so S1 is a short. Over here, we've got I1 times L1. I1 is an int, L1 is a long. So this is going to widen out to a long. Either way, an int can't go into short because int is 32-bit, short is 16-bit. Long is 64-bit, so this widens out to a 64-bit type value. It's very large. This is my 12 cubic meters of dirt trying to fit into a 1 cubic meter box. It does not fit. Java won't allow you to shove that data into a box that's too small. So this doesn't work. You can't do that. Now, if we have a problem like that, we can force it to become a narrower type. And we could do that through something called a cast. A cast is when you put a type inside of parentheses and then you put it next to an operation. So this operation here, I've got in parentheses, I1 times L1. This resolves in a long. I want the result of that whole operation to be cast or narrowed down to a short. And I do that using this cast. Now, if I take these parentheses off, let's think about how the order of operations works. The cast is going to happen before any arithmetic operations, but it happens after parentheses. So it's trying to cast I1 to a short, which it does. This is now a short. then it multiplies it by L1, which is a long. So this promotes it back up to a long. The result here is a long, and it can't go into a short variable. So to make this work, I have to make sure that whole operation gets cast down to a short. So I put that operation in parentheses, and then cast the result of that operation to a short, and then assign it into that variable that's of type short. So that's a cast. So the types of conversions that can take place. You can have arithmetic conversion, you can have assignment conversion, and you can have cast. Arithmetic conversion happens like this. This is my arithmetic conversion. It converts this I1 into F1, which is a float. So it converts an int to a float. That is arithmetic conversion. There's also assignment conversion, where a narrower type promotes up to a wider type at assignment. So this float here converts up to a double at assignment. And then lastly, we've got cast. Cast is when you force something to a particular type explicitly. All right, that's what happens when we mix types, and that's what conversions are. Thanks for watching.